In this section, we will go over 3.2, which is extreme values. We actually talked about extreme values, which are maximums and minimums in chapter 5. However, just in case you haven't watched the video or didn't do chapter 5 yet, derivatives that we have learned can help us to determine the maximum, which is the largest value, and minimum, which is the lowest value of a function over a given interval. Together, these are called absolute extrema on an interval. Well, then how do we find these points exactly? I realized that from the graphs, my maximum point occurs at the top of the curve, such as right over here, and minimum at the bottom of the curve for this graph. If I were to take the tangent of these points, I realize my tangent is horizontal for both, right? Now, this is where derivatives play a role. I know that derivative of a function gives me the slope of a tangent, but since my tangent is horizontal, I know that the slope of this would be 0. Therefore, in order to find the point, I can take the derivative of the function given, equal it to 0, and find my values from there. Maximum and minimum points can also be reached at endpoints, such as in these graphs shown. So let's say for my interval, one of my endpoints is over here, which I consider this point as my minimum instead of this point because that is lower than the bottom of the curve. But still my maximum is the same because other endpoint is lower than my maximum. Like that, I can have both of my endpoints be my maximum and minimum and not my critical points, meaning critical point like this and this. You might be also asking, what is a critical point, or it's called critical numbers. It's a point in the domain of a function where I know the function is either not differentiable or the derivative is equal to 0. So you can consider it wherever the derivative equals to 0, I call that critical point. So let's say for this as well, here is my critical point, here is my critical point, same thing over here, here is my critical point as well as the other ones. So I know at those points my derivative equals to 0. To summarize, if my function has the interval a to b, such as this one, in order to find the possible points, so critical points, I take into account two main things. First, the values I get by taking the derivative and equaling to 0, which is summarized over here. The second value that needs to be taken into account is the endpoints within that interval, which in this case I know it's a and b because those are my endpoints given. So now that we have all our points, in order to finalize on a maximum and minimum, what we do as a second step is that we take the points that we found from these two, right, and plug it into our original function given. So plugging it back into fx. So the maximum would be the largest value obtained by plugging it in, and minimum would be the lowest. So let's explore these steps with a question so it makes more sense. This question wants me to find the extreme values of the function given by that and on the interval from -1 to 5. So whenever it asks for extreme values, my very first step is to find the critical points. So I do that by first taking the derivative of whatever the function is given. So if I take the derivative of this, I apply power rule over here, so keep the constant in front the same, and then start taking the power rule into x cubed. I know that if I apply power rule, the 3 is going to come to the front. I still keep the x, but I do -1 to the power, which will give me 2. Now I apply it to here. I keep the constant same, so 9 is there. I apply power rule to x squared, which by bringing 2 to the front, keep x, and when you do -1, it's going to become 1. The constant will just become 0 when you apply the derivative. So my derivative for the function is going to be -6x squared plus 18x. Now that I have my derivative, because I'm trying to find the critical points where my slope of tangent is 0, I'm going to equal this to 0. So from here, I can see that I can actually take out negative 6x from the function. So if I do that, I'm going to end up with x plus 3, and that's going to equal to 0. So here, I can actually divide these into two sections, where I say negative 6x equals to 0, as well as x plus 3 equals to 0. Now from here, if I divide each side by negative 6, I'm going to end up getting x equals 0. So I found one of my critical points, and the other one is x equals negative 3. And I realized over here, because we took negative 6 out, this actually needs to be negative. And because that's negative, here is negative as well. So this is going to come up to positive. So just a little mistake there. So I see that when I check from my interval given, my interval is between negative 1 and 5. 0 is within the interval, and positive 3 is within the interval as well. So now my second step is actually plugging the values, critical points that I found, to my original equation. So I can summarize my critical points. So I have x equals 0, I have x equals 3, but I also need to consider my endpoints, right? Because my endpoints can also be a minimum or maximum. It's a possibility. So one of them is x equals negative 1, and the other endpoint is x equals 5. So now that I have my 4 points, all I need to do is plug it into my original equation. So I will have f0, I will have f3, I will have f negative 1, and f5. So when I plug it in, these are the values I'm going to get. What I do now is seeing whatever is my largest value, that will be my maximum. I look at my values, I have 4, 31, 15, negative 21. My largest value is right over here with 31. So I know this is my maximum. Now I look at my lowest value, I realize I have negative 21 right over here, which I can say this is my minimum. So actually, this is why it's important to also consider endpoints, is because actually one of my endpoints is my minimum, and one of my critical points is my maximum. We go into more of the word problems that you guys might encounter. So this one is saying the amount of current in amperes represented by A in an electrical system is given by the function over here. So this represents the amount of current, where t is the time in seconds, and within interval of 0 to 5. Determine the times, so I need to find the times at which the current is at its maximum and minimum, and determine the amount of current in the system at these times. So I need to find two things. So again, very first things I'm going to do, because it's asking for a maximum and minimum, is to take the derivative of the function given to me, which is right over here. We do that by taking the derivative first. So we'll start with that. So starting with negative t cubed, I'm keeping the negative. Apply power rule to t cubed by bringing the power down and do minus 1 to the power, so you would get t squared. Now I take the derivative of this by applying power rule, bring 2 to the front, do minus 1 to the power, you would get 2t. And over here, you will keep the constant, but t will just become 1 because it's t to the power of 1. So now that I have my derivative, like we said before, our slope of the tangent is 0 at maximum and minimums, so we need to equal this to 0. Just to make it easier on the eye, I'm going to divide by negative, so that would end up getting 3t squared minus 2t minus 21 equaling to 0. So now that I simplify it, I can equal these two separately to 0 to find my t values, which are critical points. So my 3t plus 7 equaling to 0, send 7 to the other side, I will get 3t equaling to negative 7. Divide by 3 for each side, so t equals negative 7 over 3. So that is one of them. Now I'm going to equal t minus 3 equaling to 0, so that I would get t equals 3, and that's one of my other critical points. However, whenever I check my critical points, I look at my interval first. So my interval is between 0 and 5. So t equals 3 passes because it's within the interval. However, this is negative 7 over 3. Because it's negative, it's not within the interval. It's only from 0 and upwards to 5. So I'm not counting this. The only critical point I'm counting is t equals 3. Now, as a second step, all I need to do is take these critical points and plug it back into my original equation. So my critical point I got is t equals 3, but however, I also need to consider my endpoints. So my endpoints are t equals 0 as well as t equals 5. So all I need to do now is plug in C3, C0, and C1 at 5. So the values I get is 4543, 040, and 545. And I see that this is my maximum point because that's my largest value. So I count this as max. And I see that this is my lowest point, which I know this is going to be my minimum. Because it says determine the times, which the maximum and minimum as well as the amount, I know that when I plug in the time and get the value of 45, the amount of current at my maximum is 45 and the time for that is 3 seconds. So with this, I can already get both of these at the same time. It's the same question as the previous one, it's just they reworded it. So for this question, it's saying the concentration represented by CT in milligrams per cubic centimeter of a certain medicine in a patient's bloodstream is given by this function, where T is the number of hours after the medicine is taken. So the patient took a medicine, and this function represents the medicine within the bloodstream. So I already know the medicine is going to wear off by the time passes by. Determine the maximum and minimum concentrations. So we already know we were finding critical points and plugging it back in between the 1st and 6 hours after the medicine is taken. What it's saying over here, it's giving us the intervals. So since T is represented by hours, so T is number of hours, I can write my interval with 1T to the 6. So I know it's between 1 hour and a 6 hour. So now I'm trying to find a critical point. Like we did before, we're taking the derivative of the function given. So that's going to be CT. And I will be applying the quotient rule in this case. So remember, be familiar with how to take the quotient rule. But just in case, I'm just going to write it. So quotient rule, I'm just going to represent it by Q. Says take the derivative of fx, keep gx the same, do minus, keep fx the same, take the derivative of gx, and then do over gx squared. So that's my formula, that's what I'm going to apply. So my fx is here and my gx is my denominator. Okay, so I start by first taking the derivative of fx, which is 0.1 t. If you take the derivative of that, that's just going to equal to 0.1 because t just becomes 1. I write my gx as it is, which is t plus 3 squared minus, keep fx the same, which is 0.1 t, and then take the derivative of gx, which I will do by, I will apply power rule, bring that 2 to the front, so that's going to be 2. Keep the inside function the same, because it is a function, it's not only t, so I will be keeping the same and multiplying by its derivative. So do minus 1 to the power, which I will be left with 1, and then take the derivative of the inside, and I realize if I take the derivative of t, that's going to become 1, and if I take the derivative of 3, that's going to become 0, so that's going to be times 1. Now that I'm done with my numerator, I'm going to start my denominator. So since my gx is t plus 3 squared, all I need to do is square this. So I'm just going to simplify it from here. I'm going to expand that t plus 3 into squared, which will give me t squared plus 60 and plus 9. And then I'm going to do minus, keep 0.1 t same for now, but I'm going to distribute the 2 into the brackets, which will give me 2t minus 6. And I'm also going to distribute this 2 into the 2, and that just means 2 times 2 for the power. So I'm going to end up getting t plus 3 to the power of 4. Now I'm going to start distributing it even further to end up with this. So now that I simplified, all I did was putting 0.1 into the brackets and then distributing the negative sign as well. So here what I realize is I have a negative 0.60 and a positive 0.60, which I can cancel those out. And I see that I have a 0.1 t squared and a negative 0.2 t squared, which I'm going to end up getting negative 0.1 t squared and a plus 0.9. So that still stays there. So I'm going to erase this and move on with the simplified version. So now that I have my derivative, all I need to do from here is equal this to 0 because I'm trying to find a critical point. Now I'm going to multiply each side by t plus 3 to the power of 4, which is just going to cancel out, and I will be getting negative 0.1 t squared plus 0.9 equaling to 0. I'm going to send negative 0.t squared to the other side to end up with 0.9 equaling to 0.1 t squared. Now I'm going to divide each side by 0.1 to get t squared equaling to 9. Now if I take the root of both sides, I can get rid of that squared. So my t is going to be 3 hours. So I found my critical point. Now my second step will be to plug that in. So I'm going to plug in my critical point, but also I know my endpoints from here. So I will also plug in my endpoints, which are 1 and 6. So I'm just going to go ahead and plug that into my calculator and as well as to the original function. And when I plug into my calculator, I see that my minimum value is right over here with a value of 0.00625. So that would be my minimum because that's the smallest value I get. And the largest value I got is right over here with 833. And that's going to be my maximum value. So my maximum concentration, that's what it wants for me to calculate, maximum and minimum concentration. You guys can put it into words saying my maximum concentration would be 0.00833, and you can say occurring at the hour 3, and then my minimum value is 0.00625 occurring at the time 1. If you guys have any specific problems that you would like to ask or regarding this video as well, anything you want me to clarify, you can actually go to our website to our forum section where we answer all of your problems.